spaghetti. So let's start again. Our next speaker is Lawley, who works with MongoDB, and he will be speaking at 10gen, and he will be speaking about writing apps with Python and MongoDB. So thanks.
That's wrong. Thank you very much. So yes, as I say, hello, my name's Lawley. I work for 10gen. 10gen's the company behind MongoDB, so we own the intellectual property, and we basically drive the roadmap for MongoDB, and we make our money through consulting and doing support and things. I work on the driver's side, so I don't actually work on building the database. I work on the connectivity between the database and MongoDB through PyMongo. I'm based in London, and we have other offices, guys who work with Python in New York and in Palo Alto. I also maintain a ODM, Object Data Mapper, called MongoEngine, which is similar to kind of how Django's ORM works, but works with MongoDB. And if anyone would like to follow me on Twitter, it's Rossi0, and I have some stuff on GitHub as well, some code examples and things, and we'll talk more about them later. So this talk is going to be is split up into two parts. By the end of the talk, I hope to give you enough knowledge about what MongoDB is, how you can use it in Python, and also give you some information of what you shouldn't do with it, or some of the bad practices or anti-patterns that you can do with it, to give you, or to ensure that you have a good time with it and you have the best relationship with MongoDB as possible. So the very first aspect of MongoDB is understanding where it came from will really help you understand why it is built like it is built and how you can use it to its best, really. So MongoDB was built by two guys, or the company 10gen was built by Dwight Merriman and Elliot Horowitz, who previously worked together at DoubleClick. Dwight was one of the founders there, and at DoubleClick they had to scale up, and they had lots of problems scaling up to serving 30 billion ads a day. And after DoubleClick got sold to Google, they went on and did another venture called TropWiki, and there they had lots of problems, again, scaling out and scaling up their databases. And the one thing that they found was every time they did this, when they scaled up relational databases, they went through lots of periods of hurt. So to begin with, when they started a project, everything was super productive. It's easy to scale and easy to be fast with a simple and small data set. But as they grew and as their data sets grew and as the requests per seconds grew and the volumes grew, they found that to be able to cope with that data, they had to start to denormalize it to be able to get the speed that they required to serve. And as they carried on for denormalizing, they went and did things like they got rid of joins totally. They started adding custom sharding layers and custom caching layers as well. And managing and dealing with sharding at the time for them meant they had to write a lot of code to be able to do that. And they had some very specific needs for their caching layers, so they had different types of objects stored. They had some documents, some images, things like this. So basically, I think Elliot built 4 or 5 different databases at ShopWiki before they came together and founded 10gen. So in 2007, they founded 10gen, and initially they were going to do a platform as a service, a kind of Google App Engine type thing, and that's what they decided to go for and where they were going to go next. When they were doing that, they wanted to build their own custom data store, and this is where MongoDB came from. So MongoDB was built to be able to, as a document database, to be able to do, and the idea is it can horizontally scale out and you can add more and more nodes to it by having documents as a different way to defining your data, and the other side is they don't have things like joins which hampered their scaling earlier on at their previous experience. Just to mention, MongoDB is literally only 3 years old, so it's still relatively new. The first release was in 2008. The first 1.0 release was, 1.0 release was in 2009 August, so it's literally coming up to its probably 3rd year of being in a production system somewhere. And a lot has changed in the last 3 years. So only in August 2 years ago did things like sharding and replica sets come in, and then later on things like journaling came in. So it has really matured in that short time and has changed quite a lot. So let's now go and focus on using MongoDB with Python and give you some examples of what a document database is and what that really means. So MongoDB with Python. First of all, what do we, as the drivers, what do we support? Well, this is our build grid for in Jenkins that we have. We support Python 2.4 to 2.7, Python 3.2 and now 3.3. I don't think it's in the grid yet. Jython and PyPy. So pretty much all those flavors of Python that if you use on whatever systems, you'll be able to use the driver to be able to interact with PyMongo and MongoDB. So first of all, what is a document database? What that means? It doesn't mean you store things like Excel spreadsheets or you store things like Word documents, which can be a common misconception. It just means you have a richer data form of how you store your data. So it's not flat like how you would store it in a table. It can be dynamic. The documents can look different to each other. There's no predefined schema when you save them. So here's an example of a JSON or a document that you might add in the shell. And here's the exact same example in Python. So you can see it maps really nicely to how you do things in Python. It's a dictionary. You still have things like lists. You can have lists inside dictionaries and stuff. And one of the key points is when we come to talk about scaling is ensuring that even though it's a schemaless database, how you use and how you model your data is probably the most important aspect on how well you can scale, no matter what. One of the good things about MongoDB is these documents allow you a lot of flexibility, but it also can mean it gives you enough rope to hang yourself with and some levels of complexity. But hopefully we'll come on and discuss more of those sides later on. The very first thing, to get started, you need to install PyMongo. All these code samples will just go work in the shell. I'll give links to some of the workshops that I did yesterday, so you'll be able to run through them at your own leisure as well. So once you've got PyMongo installed, all you have to do is go and make a connection to your database. So if it's a local database, by default, PyMongo, if you do a connection, will expect it to be on localhost. But if not, you can just pass it through a string, pass the port number through, and you'll be connected to the database. Or connected to MongoDB. The next part that we're doing here is where we're assigning db equals connection.tutorial. That's where we're actually connecting to a database. Now, in MongoDB, this is quite unusual if you come from the SQL world. There is no create database statements. There are no create tables or create collection statements in MongoDB at all. As soon as you start using something, that essentially can come into existence. So if you didn't have a tutorial database and you did db equals connection.tutorial, whichever semantics you do, as soon as you start inserting data into that database, the data files will then exist. So this is something to be wary of when you start going out into production to ensure that people do all use the same case for their database names or collection names as well, and to ensure that you don't have database objects that you don't expect to exist. So connecting is really easy. So once you have a database object, then you can start doing things like you can start looking into collections and start uploading and managing data. So here's some examples of just adding a simple document. Up here we're doing is DB for the database and then the collection name. So under here it's my collection. And then I'm just doing a save. And this is just a Python dictionary, so it can be whatever you want. It can be as complex or as simple as you need. But just for brevity, they're short here. You can use the .save method to go and save or update a document if you have it. It's kind of a gotcha to do this though, because potentially it could add race conditions into your code. So it's better to be explicit, and if you want to insert something, use the insert statement, and if you want to update something, use the update statement. We'll come on to this in a moment, but there we go. So once you have data inside MongoDB, all you have to do is call the find command, and then that will give you a cursor back, and as you iterate over the cursor, it will return the responses back. So that's very similar to how any sort of database cursors will work for you. There is a helper, just find _1, which will just, instead of returning the cursor, will return the very first match that it gets back. So it's kind of very simple to use there. Some of the things that, or you may have noticed here, we have something called _ID and object ID. And in my previous example, we had datetime objects as well for dealing with dates and things. None of these actually exist in JSON. So the JSON spec is very simple. It has arrays, nulls, booleans, numbers, and strings, and maybe a couple more. But to be able to add and deal with other types of data, like binary data, date timestamps, and things, short integers, long integers, and floats and stuff, we use BSON, which is a superset of JSON. And it's also how we store the data on disk. It has its own spec. If you're interested in understanding more about how it stores the data, you can go to the website and check it out if you want to. But what it gives us essentially is a richer way to describe our data, for dates to be dates and for binary objects to be binary, and not have to do some sort of manual mapping to decide or look into and convert strings into date objects and such. So once you have this data in, how do you go and find it? And this is where it's really flexible, but it is very different from the SQL world. There's no SQL or query language as such. It's all declarative. You provide a document example of how you want to query. So in Python, it's a dictionary, and you just give it the examples to run. So here we're doing a direct match for score, and then later on we're doing a range match. So we're doing score greater than or equals to 60, or less than or equals to 70. As MongoDB knows and understands what's inside your objects as well, you can go and query at any level. If you have nested documents in an array, for example, you can use something called the dot operator. So in the previous example, we had posts and comments was array. You could just do post.comments.author, and you can match any posts or documents that match there. Again, sorting is very similar to how you would sort stuff in a relational world. You can sort by a single field, multiple fields, that's fine. And again, you can paginate, and you can use things like skips and limits to paginate through your result sets as well. So it kind of wants to have almost all the features of the relational database in terms of being able to do ad hoc queries, find your data, and discover your data. Yeah, sure.
And did you consider using keyword arguments for functions like find?
So,
and Django like dunder GTE, dunder LTE for lookups?
So in the core library, no. It will map more how to use it currently in the JavaScript shell and keep it kind of synonymous between all the languages. In Mongo Engine, the ORM, it is a keyword like double underscore for less than and that kind of language as well. And there are other mappers that do and abstract it out to that kind of level. But by default, it is a document by example for nearly every part of the query language. In fact, for every part of the query language, sorry. So updating data. So getting into data, putting data into your application is relatively simple. Updating data is very similar again. So you will pass a query in. So what you want to update, the match part, and the second part is how you want to update it. The first gotcha we have here is kind of unexpected to a lot of people. So the very first example here, we're updating an object or a document that has underscore ID of 123, and we're updating it so score is 80. Now people don't, what it does there is it replaces the whole document and makes the document to be what that second part of the document is, score is 80. That generally is not what people want. So to do this, we have something called atomic operators, which is where we can do things like sets, unsets, pushes, and pulls to deal with and set just parts of your data. So it may be common, you'll do something like go and update a whole document in the very first example, and you go, well, where's my grade column gone? Or where's my grade field gone? And it's because if you just use an update and you pass a document, it will replace everything with that. And also, behind the scenes, save does this as well. So if you do save and you have an ID, it will actually convert it to be the very same example as the top one, which generally is not what people want. So when we come to atomic updates, what do you have? You have things like sets just to set fields, unsets to unset them. Because we have arrays as well, you have to be able to deal with them. You don't want to just set a whole array because you might get a race condition. Someone else might be trying to do it at the same time. If you tried to save the whole array or two things did, you would have a collision and one would win. So you have some operators called $push to push onto the array and again $pull to remove from the array. Then there's some other flags that you can do. For the examples here, you can, by default, it will only update the first document that matches. You can do a multiple update by passing in the keyword arguments, multi is true. And you can also use an upsert by passing in upsert is true. So if it doesn't match, it will then go and create it as well. So there's some levels of flexibility there in terms of being able to query and update your data. Briefly, indexing in MongoDB is very similar to indexing in SQL. All the indexes are stored as B trees. You can do single field indexes, compound indexes, and there's also something called a geo-index as well. Geo-indexes store things on the 2D plane. They either have a flat world model when you go and query against them, or you can have a simplified round world model. So in terms of like doing geographical lookups, in MongoDB, it's only point-based, so you can do a point in polygon or point in bounded box. It doesn't have all the features like you do in PostGIS, where you can deal with polygons and oversections and intersections of polygons as well. So it's kind of at top level, very simple. And behind the scenes, the geo-index is actually also a B tree. It basically does a geo-hash of your data. If you have multiple fields, because dictionaries in MongoDB don't preserve order, you have to use this array syntax that we have at the top there, and then just pass in tuples with what field and then the descending or descending order. To be able to understand what's going on with your database, and if you do need an index and stuff, you can have a look at the query plan, which uses .explain after your query. We'll go and tell you and give you some statistics about what that query is doing and how it's using, what cursors it's using. So in this example here, we're using a basic cursor, which means we're doing a full table scan. There wasn't an index for this query for it to use. And you get some statistics back, like milliseconds, how long it took. This is relatively small. How many objects it returned back, how many indexes it scanned, or how many objects on disk it had to go and read through. So as you scale and as you get larger and larger documents and data sets, then you can use this explain plan to find and try and debug some of your slow queries, exactly like you would do in the SQL world when you go and debug your SQL statements. To be able to understand what queries are slow for you, there's also a profiler that you can turn on. Just you probably use the JavaScript command to do this just in the shell to turn it on for a period of time. And by default, it's off. You can set it to be log any queries that are that take longer than 100 milliseconds or pass in your own threshold. Or you can have it on and flood and record every single query as well and do some of that analytics on that. Generally, I would only do that in a testing environment, but it will give you information about what queries are slow. It stores them all in another collection, so you can then go and query that collection, order them by how long they took, and start debugging some of your slow queries. Right, I think the final part we're going to talk about in terms of functionality and using in Python is GridFS. GridFS is basically a convention built on top of MongoDB that all the drivers now maintain and enforce, which allows you to use the document database as a file store. And the way it does this, it basically creates two collections in the background, one for storing metadata about the file name, and you can store any other metadata you want, the MIME type, for example, and how big the file is, or whatever you need. And then there's another collection in the background where the file gets chunked up into small chunks, and then you can just go and read back from them, and the driver itself will then go past through each chunk and return them back and stream them back. So here we have an example. It's exactly the same, or should be the same interface as how you would save a file if you were just opening a file and reading to it in Python. But you just have to make sure you connect to GridFS to begin with. It's not the most performant of file systems, obviously. There are better network solutions out there, but if you wanted a distributed or durable file system for small levels of files, then it's fine. Reading back to them, you can just read back in your application. Obviously, you're going to have to go into your application and stream it back out. That may not be the most performant for you. But there are things like plugins for Nginx, so it will speak directly to GridFS, which is orders of magnitude faster than doing it via Python. Or people also put them behind a varnish cache and cache them there as well. It kind of depends on your need. It's maybe a niche problem for you, but it may allow some flexibility for you as well. Right. So before we go on and have a look at kind of some of the scaling attributes of MongoDB, we're going to talk about object data mappers. We're a schemaless database, so why might you have them? Why do you need them? Well, generally, the main reason is if you're working in a large team, you want some way of documenting your schemas anyway. There may be a load of flexibility in there. You may or may not have fields or have needs to have fields depending on what you're trying to model. But at the end of the day, it's not chaos. You're not throwing everything in there. People will need to know what they should look for. Otherwise, you could potentially lose data. So this is one of the reasons why people may choose an ODM as well. They do things like data validation. So if you have a date field, it'll ensure that you pass in date timestamps and stuff like that as well. So it can be used for that side of things. And they enforce schema and potentially you can dry up your code. You may be able to generate forms from them because you've defined what you expect them to be. So there are a number of reasons why you should use them. They're never going to be as performant as PyMongo. I maintain one called MongoEngine. It's not as performant as PyMongo. It's orders of magnitude slower, but it may allow you to iterate and prototype quicker. So it's kind of up to you which ones to do, if you want to use one. And as I mentioned, there are lots of options. These are the ones that are mentioned on the PyMongo website. I know there are a few more. So if anyone else knows of one that's maintained, send a pull request or open a ticket, and I'd like to add it to the list as well. And there are different flavors. So if you like SQL Alchemy and you're used to doing that, you can use Mongo Alchemy because it's kind of inspired by the same API. If you want a lightweight one, there are lighter weight ones like Humongous and MiniMongo as well. And some allow you to use the native syntax for querying, like Ming, and then others actually produce their own query language like MongoEngine that uses like the Django ORM style as well. So I'm not qualified to say which one's best, but I like mine. So the best way to learn more about MongoDB and Python, or MongoDB in general, is actually to go out, download it, and play with it. So, I mean, any system that you run, if you're on Windows, Mac, or Linux, you'll be able to download it and download the database and put it on your machine. You should be able to connect to it. So there is a tutorial in the PyMongo docs. And there's also the EuroPython workshops, which are also available on the files.ep, the internal network intranet here as well. If you want to have a look, there's some PDFs there that you can run through. So I would advise to learn more about it. Just go and play with it. It'd be very dry of me to go and try and talk about building a whole application as an example, because it would be a niche problem and solving it. So hopefully I've given you some idea of kind of how you can query it. Also, there are a few tutorials as well with Python, one using Django non-rail and trying to create a tumble log that I've written there that's in the main documentation under tutorials as well. Anyone wants to supply one, I'd gladly take patches and allow them to be in and merge them into the MongoDB docs. I've written one on using Flask, for example, and MongoEngine as well, and it will walk you through building a full tumble log and get that up and running. So to find them, just go to docs.mongodb.org and then have a look for tutorial. It'll be there. So the next aspects of talking about MongoDB are, and to help you understand when you come to build your own apps, is to talk about how the durability and how scaling works with it. Now, not everyone, and there's no reason why having a single database is bad or wrong. I used to have one for just my Postgres and different things as well, and as long as I had it backed up and was happy for recovery, everything was fine within my company. But if you do have other requirements and other needs for your companies or whatever, for your projects, then the first port of call is replication, which provides a high level of durability. So to understand how replication works, fundamentally, MongoDB with replication is a single master system. So there's only one place you will ever write to. And then you'll have multiple slaves that will clone the data off. And one of the nice features about replication is it handles, or should handle, automatic failover and automatic recovery. As long as there's enough data for it to be able to catch up, if a node goes down for a period of time, as long as there's enough data on the other primary node for it to be able to catch up, it will do, and will come back into the replica set automatically. We'll talk about some of the advanced features in a moment, but if you have 3 nodes, for example, as we do here, we'll talk about the failovers of it. Principally, you have to have 2 nodes for replica sets, 2 or more nodes. But if you have 2 nodes, you can never, if one goes down, you'll only ever go into read-only. So that's something to be wary of. You have to have a majority of nodes visible, so above 50%, to be able to win an election, to be able to have a primary. If you don't have above 50%, you'll be read-only. So what happens when you set it up? You'll pass in a flag to the MongoD. You'll say use replication. It'll be the REPL set flag. You'll give a name, and you'll add some configs to say where your nodes are. And what will happen when you bring them up, it will initiate and call an election, and the primary will be elected. And it's a consensus election. The primary is voted on who has the most up-to-date data, and then some level of prioritization as well you can assign to your nodes. And the main premise is, if a node goes down for whatever reason, you might have taken it down, it might have a failure, it might be rebooting, you might be upgrading, you might be whatever. If a node goes down, and there is above 50% left, up and running, that can see each other, then between them they'll negotiate a new primary node. And it will be based on who is the most up-to-date, as I say. And then, while they're doing this negotiation, they are in secondary. So your application is in a read-only state. You can't accept writes. When you have a primary, the secondary will start copying the data over again. And hopefully your other node will come back up. You've rebooted, you've upgraded the OS, whatever. And if there is enough data in the primary still, using its operations log, so if the secondary that went down is within the window of opportunity to be able to catch up, it will automatically catch up. And it will do this and go into something called recovery mode. If it can't catch up, you will have to manually bring it back up. It's not magic. You will have to manually either get a backup or blow away the data and allow it to stream back over from the primary. So, but in the most run, during normal operations, it should be able to recover naturally and automatically. And there you go. And then you have your replica set reestablished. So there isn't. It's not magic, it's just that's how it does. It tells what operations are happening on the primary, so what updates are happening on the master, and then applies them to themselves. There are some advanced features that you can do this. So you can take this quite far, and there is more control over this in MongoDB than probably anywhere else. So you can do things like you can add extra durability when you do your writes. So when you do an update in MongoDB, by default it does something called a fire and forget write, which is asynchronous. It doesn't even know if the database got that update or that insert, which is probably not what you want and isn't the best of, arguably isn't the best of defaults, but it is what it is. So most people will do something like they'll say, I want it to be applied to memory, and this scales all the way up to, I want to ensure that it hits 2 of my replica sets. So if I accidentally lost one of my nodes, I want to ensure that the data exists on at least one of the other nodes, so I don't lose that node. Even if there is a severe hardware failure, you will have that level of durability. Obviously, it's going to block while it waits for the replica set, the secondary to apply that operation. So you can go from totally non-blocking to being lots of blocking, essentially, or longer times of blocking. You can do other things like prioritization. You can say, and I'll give an example in a moment, but you can prefer some nodes and to others. And potentially you can scale out your reads. You can read directly from the secondaries. But the secondaries may not be up to date. So here's an example of a setup that we might have. This is a 5-node replica set. We have one that has a priority of 0 in the USA in this example, we have our primary data center that's in the EU, so we've given them a priority of 10. So we're always going to prefer that because most of our users are there. And then the USA one might actually just be another data center. It doesn't really matter. But that one has a lower priority. So we could prefer, if something happens to the EU node, if that availability zone went down, I would still want, okay, I still want to be able to cover it and be able to handle. So then the P5 would be the option, and you could still use that in the USA. And here's an example of what a lot of people will do. They'll have a node that's set to priority 0, which means it can never become the master because they may do secondary things on it. They may use it for backups, they may use it for reporting, analytics, that kind of thing. There's a lot of documentation, a lot of other presentations that go into a lot of depth about replication, about different levels of durability and stuff. So if you're interested and that's your need, do just read up about it. It's all there and it's all available on the 10gen docs website. The next part is sharding. I'm going to cover this in even less depth because this is kind of levels of scaling that if you need it, it's kind of conceptually easy to do, but it can be expensive. A lot of people may do it prematurely because it's easy to set up and it's fun to have lots of boxes, but if you don't have a level of scale that needs it and you just want durability, then replication is probably your best bet. Yeah. So scaling out, I'm going to go. In theory, you can go from a single node, which is fine, which gives you that bottleneck. You can only go as big as that node can go. Then you can go to replica sets, where you'd have one primary, and potentially you could read from the secondaries. And then you can go through, and you can basically put a layer of sharding on. Sharding is, you shard a single collection, and you say, I want to split this collection up by a key. There is some granular detail of what you need to do there, but it's best to look into the documentation, or if anyone's got questions on it, come and ask me afterwards. It handles automatic ranging and balancing. Should you need it, you can turn this on or off depending on how much you want to be involved in administrating your sharded set. It's range-based, so you provide a key and it splits up your data into ranges and migrates that data. And essentially, because you have multiple primaries now that all deal with a subsection of your data, you can scale up because each of them can deal with more load than a single node. So the premise is kind of simple. Here is an example of a very durable setup that some may have used for sharding. So you need configuration servers. These deal with information about where the ranges of data exist. And each of the colors, the green, yellow, and reds, are different replica sets. And what they've done here is they've striped them across. They've given across availability zones. So if an outage happened, if Dublin got hit and you're on Amazon by lightning and you lost that, you would be able to recover from it, or whatever. The premise is, and they've also played with priorities to stripe their priorities across. So they have tens and difference of nodes. They lost an availability center. Only a subsection of their website or users would be affected for a limited period of time while it brings up and elects a new master. So there's a lot you can do with it. Any questions, come and ask me. I'll put this up. This is basically lessons. I've lost that one. So web scale, I'm not going to let you take a photo of that, but because my bosses might be angry. Scaling I've talked about, and we are kind of, when we go and give these talks, we talk about these things and say, look, replication there, you can scale out reads, and you can scale up, and you can deal with sharding. It's simple and easy. But the truth is there's no magic bullet. And because you have things like JSON documents, it may help you or it may be a hindrance. It depends on what your application does. So there's no miracle grow. You can't just expand and grow as this product does here. Essentially, scaling is hard. It's a challenge. You have to understand what are the expectations of your system. So if you're a read-heavy system, then having a large, complex document might be great for you. If you're a write-heavy system, then having easy to insert and update writes is a different proposition. If you have requirements to be able to return back in sub 50 milliseconds back from the database, then you're going to have a very different sharded setup than you would do if it doesn't matter how long reporting takes, but actually I just need small portions of my data in RAM. So there's no magic solution to it. It's kind of the main point. As I alluded to earlier on, don't be premature. Setting up sharding with MongoDB is a doddle. You can set it up on your local machine. It can take you 30 minutes to have 9 different servers running on your local machine and doing a fully sharded system for you. just so you can play with it. That's great, but if you don't need that level of scale, don't do it. Don't go out in production just and buy servers and things. I've seen it many times, but if you don't need it, don't be afraid to change and iterate through your requirements as you and your applications change. You will lose all your data. Right, so this misconception comes about, or people not understanding their write concerns. So by default, they're fire and forget, which means, when we have a look at it, the driver will just say, primary node, write this data, and will not wait for a response. So if you had a unique key collision, you wouldn't get any information back about that. So unless you speak to the server and say, did you get it, or what's going on, you're not going to know how durable that data is. So as I mentioned too, when you have replica sets, this can scale out as much as you want. You can do things like, I want to make sure at least 2 of my nodes got the data, and you will block for a longer period of time. But for most applications, the minimal write concern you want or need will be to ensure that it's written to the journal and the journal's flushed to disk. So if you're doing an update, all you have to do, or an insert, is just put journal equals true as part of it. Or just write a helper function that does it for you, and you just wrap that. But that is the most common part. Not necessarily all your writes to the database need to be on the same write concern as well. So if you're just storing log data or tracking mouse clicks over a screen, you may just say throw them in memory and do the first option. If you're creating a new user who has an account, you may want to do this option to ensure that that data is fully durable. So you have a lot of flexibility there, but it's important to understand what your needs are for your system. The higher your write concern, the longer it will block. That will impact your system more, and the speed and performance of it. Anti-patterns. Right. Schemaless doesn't mean chaos. So just because you can doesn't necessarily mean you should. I have a slide for that as well. So bad things are, don't put everything into a single collection. Be explicit about what a collection means. Keep things of a type together. There's no necessarily one size fits all. It's probably not a good pattern for you. Don't over-index, don't under-index. These are very similar to the SQL world. Unbounded arrays cause problems because if you're continually adding to an array, that may impact your performance. It's great if you've got a small machine, small amount of data. It's going to perform fast. But if you get bigger and bigger and you start adding the 10th million or the 100,000th thing to an array, every time you add to that array, it's going to scan through it, and that will slow and impact your performance. So that has a real bad code smell. I'm not saying never use it, but just prove it when you're with your tests if it's right for you. Similarly, arrays that store all the data. So there's quite often you'll see the post comment with the post example with an array of comments in there. Now, that's fine for displaying it. You can just do a single query, whack that back out into the front end, and that might be perfect for you extremely fast. But if you wanted to find all the comments where someone had queried or do any level of analytics on items in an array, then there's a problem. Because when you do queries in MongoDB, you do queries against the document. You don't do so you can match against subparts in an array, but if you did the match, you will return the whole document around and all those items in that array, and you'll have to manually filter them out. So that potentially could be a code smell. You may want to separate them out into another collection, or do a combination of both. You may denormalize and have the latest 5 comments in one place, and then all the comments somewhere else, so you can do your aggregations over it. References everywhere. Okay, so people treat MongoDB, they come to it, especially if they use some of the ODMs, Mongo Engine including, and treat it just like a relational database. They put foreign keys essentially everywhere, which costs lots of queries going back and forward to the database. You can't do joins, so to deal with a foreign key or links to some data, you do 2 queries. You do one to get the data and another to get all those references and back and then merge them together. So if you're doing too much of that, or if you need things like transactions, whatever, then those things allude to that SQL might be your better solution. Just because it's new and different doesn't mean it's the right job. Massive embedded trees. We can give examples of good schema design of why a tree is good, but honestly, if you need trees and you need massive trees, and you need to query and find relationships between things, use a tree database. As I say, just because you can doesn't mean you necessarily should do this. So a lot of things are like that. And essentially, use the right tool for the job. If you need transactions, if you need to be able to roll back and do multi-phase commits, MongoDB doesn't provide that. People will write it in their code. It will bloat their code out. That should give you warning signs in your head, because the idea of it should be useful. It doesn't mean that you can't just, or you have to just use one database or one database types. We have people who do things like shops that will deal with the checkouts and the transactions in the SQL database, and they'll deal with products in MongoDB, because products have different types of schemas and describe themselves differently depending on the types they are. So please use the right tool for the right job. Don't just troll and say MongoDB broke everything for you, because that can also happen too. But please understand, you don't just have to pick a single item. Best practices. So all I'll say, the best practice for anything dealing with data is just to prove your use case of it. Test and test again. So we provide lots of tools for dealing and scaling yourself up. That's great. And we provide ways of easy management of it. Doesn't mean that your data models work and scale well. The only way to do that is work out what your application does, if it's read heavy, write heavy, those kind of things, and then test it. And then test it a little bit more, break it, and find out where the points are in MongoDB at this database layer that don't scale or are inopportune for you. And then try and prove that your schema works and is useful for your use case. That's kind of it. So, questions? And the first two questions get a book. So, well done.
One of the slide, actually you showed 3 nodes, and if one of them is down, then you're still able to select a primary node from that, or a master node from that. So is there an entity which sits and works as a proxy, like MySQL proxy, which lets...
Okay, so when we're talking about elections and how does that work, basically the servers all heartbeat each other. They all keep a status of how they see the replica set. And if a node fails, and they fail for 3 times, so 3 heartbeats it fails, they will call an election. And it's a consensus election, so they will go, my data's up to date to this, I priority such and such. And then one will say, yes, I should be the master, and this election process will take, or potentially can take, a number of seconds. So you may be in a read-only state for a number of seconds, but given that if you, as long as you have a majority up and available, so as long as there's over 50%, then a primary will be elected. But there's no other system that you have to run in the background to do it. It's the MongoDB, the database itself. When you set it up with the REPL set flag, that's part of the code that's in there. So how's the traffic routed? Well, they're speaking to each other and heartbeating and basically running stats on each other. So all the nodes have to be able to communicate and discover each other to be able to understand it. How the traffic from the driver is routed is when you're using replica sets, you'll use a replica set connection and you'll provide a seed list. And from that seed list, the driver will speak to the replica set and get the full seed list of the replica set. So if you provided just one single node, as long as it was up and available, the driver would then get the full topology of the replica set. So come see me afterwards, because the lovely lady from O'Reilly gave me a couple of books to give away, so you can win one.
I used to have this problem, and I just checked it again with latest driver, and nothing changed. Actually, when I put the high load from the Python to the Mongo, more than 30% of the time computer spent in the Python wrapper, and only 30% in the Mongo. So it looks like PyMongo is quite unoptimized. Yeah,
so talking about optimizing of PyMongo, the driver, there are things you can try and do. So someone came up to me recently in London and said, I'm doing something in C++, it's extremely fast, and why is it 20 times slower in PyMongo? And basically, as soon as they started manipulating something like batch size to ensure how much results they get back from the server, it did less traffic and was a lot quicker. So I'll come chat to you or come grab me afterwards so I can get some more specifics, but I know that batch size is one area that has been sped up. We also, not only do we have that grid that I showed earlier on in terms of just performance, in terms of which versions of Python we test against, we are now having performance testing to make sure we don't regress and we continually improve performance. So,
I installed PyMongoDB and MongoDB on my machine, and all of a sudden my var partition was eaten up because there was it took up some 2 gigabytes of memory,
Sure.
just empty. So can you
Yeah.
say something about memory performance?
Okay, so, yeah, sure. So memory-wise, MongoDB is hugely memory hungry. All its data files are mapped into virtual memory to try and make it efficient. The other thing it does is it pre-allocates space. So if you have a data set, it starts off with small data files of like 64 megabytes and doubles up to 2 gigs. Now, if you have over that level of data, you'll have a whole file that's 2 gigs of data absolutely empty. Now, if you're in a test environment, that's wasteful, and there are things you can do. You can pass a flag in saying no pre-allocation, so you won't create these extra files until they're needed. The idea is if this file exists on disk and you've got high write levels, you'll be able to scale out those write levels because you'll be able to have a place to put them, and then it will start pre-allocating another file. There's another thing you can do is you can also pass in a small files flag as well to decrease the size of the files to begin with. So they'll be smaller to begin with and scale up. So there's multiple opportunities there that you can do. But yes, it is extremely memory hungry, and if you have other things on your system contending for memory, that will impact your performance as well.
Quick question. Have you ever heard of a hybrid solution between NoSQL and MongoDB? A SQL solution and MongoDB? Or is it sufficient to use MongoDB and the GFS solution for binaries?
So people use, I would definitely argue using a hybrid solution for anything. Like, use the best tools for the job. That means if you're using SQL for certain things, for very structured schema data, that's fine. OpenSky is a shop thing. I know that they use both. They use the SQL database for dealing with some of their structured data, and then some of the more unstructured data is in MongoDB as well. So it kind of, use those tools that you need them. If you need a graph database, just because you need a graph database doesn't mean you have to use Neo4j for everything. And so, mix and match and make the technology work for you.
So I had a question about the elections and sort of the self-healing aspect.
Yeah.
So in the scenario where you had the five nodes, and you've lost what typical absolute worst case scenario, you're stuck back on the primary node has somehow managed to end up on your 0 priority node.
Okay, it won't be on the 0, but because 0 means it can never be.
Related question: what would happen then if you haven't got anything but that 0 node left?
So if you had no other nodes left that could become primary, and if you have less than 50% anyway, you're going to go into a secondary system. So you're going to be read-only, and you're going to have to manually intervene. Okay. So it's kind of, you can choose what to do then. You can reshape your thing and say, okay, I'll now make that a node that can accept writes.
So my primary thing was dealing with, let's say your priority 10s have disappeared, and then you bring them back up again.
Yeah.
Does that automatically trigger a new election, or?
So when they come back up, the topology will change, but you may have to manually go and intervene to ensure, because they're going to, potentially how long they're going to recover, they're going to be behind. So you may go in, run a command in the shell to actually take the current primary down and force an election when you know everything's up and running. So, you're going to have to manage that yourself, essentially. Okay, I think that's everything.
Any other question? No, so thank you very much.
No problem, thank you.